Okay, in this video, we're going to look at actually solving some of these linear word problems, and we're not going to be given a graph or an equation to work with, so we're going to have to make our own. And let's look at this first problem that we have. So Dominic is going to drive from his house to City A, and he's not going to stop. His house is 300 miles from City A, and he plans on driving at a speed of 50 miles per hour. Now, they want us here to write the equation of D in terms of T, representing his distance from City A, T hours after leaving his house. So, what we have is, so we need to write our equation as D equals. So, I want us to write an equation for D. So, D equals, and then our variable in this case is going to be T. So, City A is 300 miles away from him. So we start with 300. So if he doesn't drive at all, the distance away is 300. Now, for every unit of t, or every hour of t that he drives, he will decrease his distance by 50 miles. So we'd go 300 minus 50 times t. Now let's look at the second one. All right, Nolan's given a box of chocolates on his birthday. Each night, Nolan likes to eat some sweets, so he eats some chocolates. There were originally 30 chocolates in the box. After 8 nights, he only had 6 chocolates left. So I want to write an equation for C in terms of T, representing the number of chocolates that will remain in the box T days after his birthday. So all we really know is that Nolan started with 30 chocolates. So if he started with 30 chocolates, that means when T equals 0, the number of chocolates equals 30, which I can think of as a coordinate 0, 30. And then the other piece of information they give me is that after 8 nights, so when T equals 8, the number of chocolates is equal to 6. So C is equal to 6 here, which gives me a second coordinate that is 8, 6. And we want to write an equation with that kind of information. Well, to write the equation, we need to know the y-intercept. We need to know the slope. So the slope here of this line, or the rate of change in which he's eating chocolates, we're going to go y2, which would be 6, minus y1, which is 30, divided by x2, which would be 8, minus x1, which would be 0, and then we would simplify that, and we'd have m is equal to, what is that, negative 24 over 8, which is going to give me negative 3. So he's eating 3 chocolates a day. So I have my slope, and so we want to write our equation y equals mx plus b here. Well, instead of y, we're going to use c. Our slope is negative 3, so I have negative 3 instead of x. They want us to use t. And then the y-intercept, how many chocolates did you start with? Well, they started with 30 chocolates. So it'll be negative 3t plus 30. Okay, let's look at one more of these where we just practice writing an equation. Anna is moving. It's got to rent a truck. In addition to an initial fee, the rental company charges $3 per mile. If Anna drove 5 miles, her total cost would be $50. So I want to write an equation for C, the cost of the truck, for Anna to drive M miles. Well, we do know that we have to pay $3 per mile. Now that is a rate, which is the slope. And we're also told that if we drove 5 miles, the cost is 50. So we have a coordinate that is 5, 50. And we want to write the equation. So we have a data point, and we have the slope. Remember this formula we have? We can write the equation of a line. That's y equals f of c plus m times x minus c. Well, c is 5 in this case. F of c is 50. And we know m is 3. So our equation here would be y equals 50 plus 3 times x minus 5. And we distribute that 3, and we get y equals 50 plus 3x minus 15. And all we need to do is we need to combine like terms and get our letters right. So they want us to have c and m. So we would say the cost to rent the truck is going to equal, we would have, instead of 3x, we'd have 3m, so $3 per mile. And then 50 minus 15 makes plus 35. And so there's our equation right there. Okay, now let's do some more applications. But now instead of just writing an equation, we're going to work around some tables and try to solve some items. So we're given a situation, and I have that organized where I got the table in the middle and then what we're looking for in the column on the far right. So here in this first problem, Isaiah sells computers at an electronics store. He's paid $5 commission on every computer that he sells, and he's also guaranteed to make a base pay of $100 per day. So I want to fill in the table of values for how much money Isaiah is going to make. So if he sells 0 computers, his profit in this case is going to be what he's guaranteed to make of $100. So he makes $100. So he gets $100 no matter how many computers he sells. Now, if he sells 1 computer, he gets a $5 commission on top of that. So his daily profit is going to be 100 plus 5, 105. If he sold a second computer, he's going to get paid another $5, which means that his profit for selling 2 computers would be 110. If he sells 3 computers, he gets a third $5 bill, which means he gets to walk out of there with $115 profit. So what we want to do is we want to write an equation representing his profit in terms of X, representing Isaiah's total pay on the day where he sells X computers. Well, his initial base pay of 0, 100. So I'm trying to write this thing as y equals mx plus b form. I know b is going to be 100. It's his base pay. Now, M is how much money did he make per 1 computer. He made $5 per 1 computer. And so we can plug this in, and instead of y, we're going to use p. And so we'd say p equals 5x plus 100. Now let's look at a different style problem. So Allison is in the business of making phones. She's got to pay a daily fixed cost to rent the building and equipment. It also pays a cost for every phone. So there's a cost per phone that's made, but just for materials and labor. And so the end game is to figure out, well, what's the fixed cost if you didn't have to make any phones? Well, we're given this table. We have this table here where we have P, which represents the total number of phones. So P is the number of phones. And C is the cost for the day. And we want to take that table and figure out, well, what was the fixed cost for renting equipment? We have to kind of do a lot of work to do this. We are given data points here. And so we're going to start by finding the slope. So we're going to pick 2 points here. So I have a coordinate of 3, 900. And I have a coordinate that is 7, 1300. And I'm going to find the rate of change for every 1 phone. So I'm going to find my slope, x1, y1, x2, y2. And so the slope here is going to be 1300 y2 minus y1, so minus 900, over x2 minus x1, 7 minus 3, which is going to give me 400 divided by 4, which equals 100. So it cost us $100 per phone to make. Now, since we have that table there, we can continue that table and figure and make a prediction as to, well, what would the cost be for 2 phones, 1 phone, and 0 phones, because the cost to make 0 phones would be your fixed cost. Well, for every 1 less phone that we make, we're going to deduct $100 off the cost. So if it costs to make 3 phones, it costs $900. To make 2 phones, it'll cost $800. Then to make 1 phone, it'll cost $700. And to make 0 phones, it costs $600. So the fixed cost just to rent the building and the equipment for the day was $600. We have another one. Let's see. Joe just lit a brand new candle and he's letting it burn all the way down until the whole thing's gone. So L in this case is representing the length of the candle remaining in inches after T hours since it was lit. So we want to use this table to determine what was the length of the candle after it burned for 2.5 hours. And we don't have an equation to use. And the 2.5 is nowhere in my table. So what I'm going to have to do is I'm going to have to try to see if I can't make me an equation. Or at least I got to start by trying to find the slope of this line. So I'm going to take 2 points. I'm going to find my slope. So my slope, y2 minus y1 over x2 minus x1, is going to be, I'm going to say 4 minus 7 on the top. Y's are really my L's. T's are my X's. And so over 6 minus 3 on the bottom. And so M in this case is going to be -3 over 3, which gives me -1. So what that means is the candle gets shorter by 1 inch per hour. And so I want to know, well, what's the length of the candle after 2.5 hours? Well, what I would need to do is take the point that we have. We know it when t is equal to 3, the length is equal to 7. And so when it burns longer, it gets shorter. So if I go back and say, well, all right, well, using that information, how long was it when time was equal to 2? Well, it was going to be 1 inch longer than what it was because it's been burning. So when time is equal to 2, the length was 8. We want to know what was the length at 2.5. Well, 2.5 is going to be halfway in between there. So the length was 8.5. Okay, let's look at one more of these tables. So Gabby's going to drive from her house to City A without stopping. D represents her distance from City A after leaving her house. So I got the distance from the city after she's left her house. I want to determine how long Gabby has been driving when she was 105 miles from City A. Well, I don't see 105 miles anywhere on my table. So what we're going to do is we're going to try to figure out, well, how fast is she driving? Maybe that will help us determine that. So I'm going to take 2 points here. All right, and we're going to find her speed, which is the slope. So y2 minus y1 over x2 minus x1. And that's going to give us 75 minus 120 over 3.5 minus 2. And so our slope in this case is going to be, we'd have a denominator at 1.5. 75 minus 120 is 45. Now we want to know what 45 divided by 1.5 is. Usually on these kinds of problems, you're going to have a calculator. So 45 divided by 1.5 is going to equal. So usually in these kinds of problems, you're going to have a calculator. But 45 divided by 1.5 is 30. So 30 is, and in fact, it should be negative here. So it should be negative 30. So 30 is the number of miles she gets closer for every 1 hour. So Negative 30 miles per hour is the rate of change in her distance per unit of time. So I want to know, how long has Gabby been driving the moment she's 105 miles away from City A? Well, let's go find a number that we can use to easily get to 105 by adding or subtracting 30 from it. And what I'm going to do is I'm going to look at this point right here at 3.5 by 75. So I know when t is equal to 3.5, her distance from City A is 75 units. So for every 1 hour that I add to that time, she's got to get 30 miles closer. So for instance, if I said, okay, when time was equal to 4.5, her distance, she'd be 30 miles closer. So I'd take 30 away from 75. That gives me 45 miles. Now notice I want to look at 105. So I need to go the other way. So let's add an hour back to 3.5. So when we at 2.5 hours, her distance would be 30 miles farther away. So I'm going to add 30 to 75. That gives me 105. So how long has she been driving? She had been driving for 2.5 hours.